Hello scholars, welcome. Mr. Hinkle here. We're talking about fossils and how fossils become preserved into the stratigraphic record. Let's get into it. Our objective, define preservation, discuss the conditions and types of fossil preservation. So preservation is a process where the remains or the traces of once living organisms are protected from decay and they survive becoming fossils through geologic time, the span of Earth history. This allows the fossils to become part of the fossil record, providing insights into ancient life and environments. I go over this in more detail in my introduced lecture. Fossilization process where the death of an organism is buried, lithified, preserved into the rock record. So, the requirements for a fossil is that there are preservable parts. Some parts of organisms are more easily preserved. Teeth, bones, shells. That the organism is rapidly buried by sediment, and that in this rapid burial there's usually low oxygen and the organism avoids destruction or decay through physical, chemical, or any kind of biological means. So, if these conditions occur, we may have fossilization happening. Well, there's different modes. Here's the short list. I'm going to go over them right now. Preservation of unaltered remains. This is the least common, but can be very, very beneficial. We've got a couple examples. This woolly mammoth discovered being frozen for 4,200 years. We also have Otzi the Iceman, O-T-Z-I, which is an actual human being preserved in the high Alps. This is a murder mystery story because they discovered that he was shot by an arrow in the back. He had a copper axe that was still on him at the time. If you're like, ooh, that's interesting, definitely check out some great National Geographic documentaries on Otzi the Iceman. But preservation of unaltered remains can happen through deep burial, freezing, desiccation that's being completely dried out, preservation in amber. Amber is a mode of fossil preservation. Tar or peat bogs. Just how it sounds, the organism is preserved unaltered with its skin, with its fur, with its feathers. Wildly important or informative, I guess I should say, for understanding the history of that specific species. Permineralization. You may know this most commonly as petrified wood. When minerals deposit into the pore space of an organism's remains, it happens when the organism is buried in sediment, the water moving through the sediment is mineral rich, and the minerals deposit silica or calcium carbonate. We see this often in wood, in dinosaur bones. This is a very common form of dinosaur preservation, and then also in marine fossils when they deposit at the bottom of an ocean basin. Carbonization is when an imprint is left in soft sediment. So we've got a multi-step process. Organic tissues of an organism are compressed. The volatiles are driven out. Everything but the carbon disappears, leaving a carbon silhouette. So leaf imprints that you often see in fossils are, and actually I've got one right here. Let me grab it. This fossil that I'm grabbing, spur of the moment, sometimes you think about these things in real time, is an example of one of Alfred Wegener's 4 lines of evidence. This is a Glossopteris fossil, widely distributed on Antarctica, South America, South Africa, India, and Australia, giving us clues to the formation of Pangaea and the subsequent splitting, which supports the theory of supercontinent cycles proposed by J. Tuzo Wilson, and it's actually named after him, called the Wilson cycle, which is pretty cool. But it's not exclusive to leaves. Fish, insects are all able to leave their carbonized imprints behind. So carbonization. Replacement. This is when there are parts of an organism, original minerals or organic material that are replaced with different ions in the water. So permineralization is filling in the pore space. Replacement is going to be actually transformation of the original material into another. Silica, pyrite, common replacement minerals. These give a lot of detail, as we can see here in this trilobite that has been replaced with the mineral pyrite. Recrystallization is another process where instead of replacing the minerals, the ions that are already there reorient, recrystallize. So you have calcium carbonate turning into aragonite that can, so it's calcite becoming aragonite. The overall shape is preserved. Maybe you don't get the finer details, but you still get a lot of understanding for what the original organism did look like. So different environments will lead to different preservation modes. Ultimately, the end result for all of these is that the remains of the organism are preserved in the rock record so that you and I can study them and we can learn about them and we can gaze in awe and wonder at what the history of our Earth must have looked like. Very different than today. Let's keep going. Molds and casts. Very similar to your ice tray is a mold. You fill it with water, it freezes, you pop out the ice, that's a cast. If you've ever done any other kind of mold and cast art projects, but you can have different shells of organisms or pieces, parts of the organism imprinting into soft sediment, which later then get filled in. That external mold creates a cast, and that cast allows for us to understand what that organism must have looked like. Molds and casts are also very common for displays in natural history museums when maybe the original material we don't necessarily want to be exposed to the elements, so we create, and if we're moving it from one display to another, then what you actually see, the big dinosaur bones, aren't the actual dinosaur bones. They're a mold and a cast of the original dinosaur fossil. That is okay. Here, the most complete and famous Tyrannosaurus rex fossil. How awesome is this? Whoa, that is so cool. But it's a cast, it's not the original. This thing moves all over, it's heavy to mount, so we can still get an idea without needing the original. Trace fossils is just how it sounds. This is the footprints or the remains. It's showing indirect evidence of the activity of an organism, which in and of itself is extremely valuable. We've got a lot of different types of trace fossils: tracks, trails, burrows, borings, root marks, nests, eggs, coprolites, a really fancy science word for poop, and bite marks that can be left on trees or wood. So lots of different ways to understand the behaviors and the movements of organisms by the indirect evidence left behind, also preserved in the stratigraphic record. Okay, so in conclusion, fossils are the remains of once living organisms that are preserved in the rock record. To be preserved, they need to have preservable parts, to be buried in sediments, and to escape destruction. If an organism can meet all three of those requirements, then there's different ways it is preserved. Completely unaltered, that's awesome when it happens. permineralization, carbonization, replacement, recrystallization, molds and casts, or the evidence of their existence, trace fossils. Thank you so much, and I will see you again.